Hi everybody, welcome to my channel again. This is Algebra. We are finishing up section 1.7 today, as well as chapter 1. So this is the last video of chapter 1. We're going to look at review for mastery problems and challenge practice problems. The goal in this section 1.7 was to represent functions as graphs. So problems 1 through 4 here that you see on my screen, we have to make an input-output table for each of these 4 problems, and then we have to plot the points for the ordered pairs that we're going to get on a graph. So let's start with problem 1. The first function is y equals 1/2 x plus 3. So let's draw the xy or domain range input-output table. So we have 0, 2, 4, 6, and 8. When x is 0, 0 times any number is 0, plus 3 is 3. When x is 2, 2 over 2 is 1, plus 3 is 4. When x is 4, 4 divided by 2 is 2, plus 3 is 5. When x is 6, 6 divided by 2 is 3, plus 3 is 6. When x is 8, 8 divided by 2 is 4, plus 3 is 7. So if you draw these, if you plot these points on the graph, we're gonna get, so let's see, this is 0, 0, then we have 1, 2, 3, 4, 5, 6, 7, 8, then we have 1, 2, 3, 4, 5, 6. So 0 and 3, 0 and 3 would be right there. 2 and 4, 2 and 4 would be right there. 4, 1, 2, 3, 4, 4 and 5. 1, 2, 3, 4, 5, 1, 2, 3, 4. So it would be right there. 4 and 5, and then 6 and 6 would be right there. And then 1, 2, 3, 4, 5, 6, 7, 8, 8 and 7. So it will be somewhere there. Okay. Next one is 4x minus 4. The domain values are 1, 2, 3, 4, and 5. When x is 1, 4 times 1 is 4, minus 4 is 0. When x is 2, 4 times 2 is 8, minus 4 is 4. When x is 3, 4 times 3 is 12, minus 4 is 8. When x is 4, 4 times 4 is 16, minus 4 is 12. When x is 5, 4 times 5 is 20, minus 4 is 16. And let's see if we can draw another graph. So x, we need 5. 1, 2, 3, 4, 5. For y, we need 16. So we can do maybe 4, 8, 12, 16. 4, 8, 12, 16. And this is 1, 2, 3, 4, 5. So when it is 1, x is 1, we have 0. So this is 1 point. 2 and 4, 2 and 4 would be right here. 3 and 8 would be right here. 4 and 12 would be right there. And then 5 and 16 would be right there. Okay. Number 3, xy, 0, 4, 8, 12, 16. The function is minus 3/4 of x plus 6 when x is 0. 0 times any number is 0, plus 6, 6. When x is 4, 4 and 4 cancels out, so minus 3 plus 6 is plus 3. When x is 8, 3 times 8 is 24, over 4 is 6, minus 6 plus 6 is 0. When x is 12, 36 divided by 4 is 9, minus 9 plus 6 is minus 3. 16, 48, minus 12 plus 6 is minus 12 plus 6 is minus 6. Okay. So let's have another graph. let's have it right here, x and y. So x, we have 0 to 16, so we can do 4, 8, 12, 16, 4, 8, 12, 16. Then for y, we have 6 and minus 6, so we can do maybe 3 and 6, 3 and 6, and then minus 3 and minus 6. So 0 and 6, 0 and 6 is right there, 4 and 3 is right there, 8 and 0 right there, 12 and minus 3, and then 16 and minus 16, 16 and minus 6. All right, number 4, the input-output table. Okay, so the values are 1, 2, 3, 4, and 5 for x. And for y, when x is 1, we have minus 2 plus 7 is 5. When x is 2, we have minus 4 plus 7 is 3. When x is 3, we have 1. When x is 4, we have minus 1. And when x is 5, we have minus 3. And let's plot that. X and y. So for x, we have 1 to 5. 1, 2, 3, 4, 5. For y, we have, let's do 5. 1, 2, 3, 4, 5. 1, 2, 3. So the first one is, the first point is 1 and 5. 1, 2, 3, 4, 5. So it's right there. Next one is 2 and 3. It's right there. 2 and 3. And then next one is 3 and 1. It's right there. Next one is 4 and minus 1. 5 and minus 3. So that was number 4. Next one is 5 and 6. Write a rule for the function. Identify the domain and the range. So domain and range. The first point is 0, 0. Next one is 1 and 2. Next one is 2 and 4. Next one is 3 and 6. Next one is 4 and 8. The domain values are 0, 1, 2, 3, 4. The range values are 0, 2, 4, 6, and 8. The function is going to be, see the domain values, they increment by 1. The range values increment by 2. So this will be 2x. Let's see if this works. When x is 0, 0 times 2 times 0 is 0. When x is 1, 2 times 1 is 2. When x is 2, 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. So yes, y equals 2x is the function. Next one, number 6, domain and range. First one is going to be 0 for x, 0.5 for y. Next one is 1 for x, 1.5 for y, 2 for x, 2.5 for y, 3 for x, 3.5 for y, 4 for x, 4.5 for y. The domain values are 0, 1, 2, 3, 4. The range values are 0.5, 1.5, 2.5, 3.5, 4.5. The function would be, we see the values increment by 1, also the range values increment by 1. So this would be x and then plus 0.5 or 1/2. So when it's 0, 1/2 is the answer. When x is 1, we have 1.5. When x is 2, 2.5, and then 3, 3.5, 4, 4.5. So this is the function y equals x plus 1/2. Next is problem solving workshop, mixed problem solving. There are about 8 problems, so let's see. Number one, multi-step problem. The table shows the number of grams of protein and the number of calories from protein in 4 different foods. Number of grams of protein P, 6, 8, 12, 15. Number of calories from protein C, 24, 32, 48, 60. Use the table to write a rule for the food's number of calories from protein as a function of their number of grams of protein. Okay, so this is Y or C, and this is X or P. So these, see, they increment by 2 and then by 4 and then by 3. So there's nothing that we can do there. Let's see if there is a relationship between them. 24 minus 16 minus 6, that's about 18. This is 24. So nothing. How about multiplication times 6 times what is 24? 4. 8 times 4 is 32. 12 times 4 is 48. 15 times 4 is 60. So C or Y, you can say it's 4 times P. That's the rule for the function. C equals 4 times P, or Y equals 4 times X. Okay. B, another food has 17 grams. So another food has 17 grams. What would be, predict the number of calories from protein. So it's 4 times P, so 4 times 17. So C, it's 4 times 17, or that is 4 times 10 is 40, 4 times 7 is 28, 40 and plus 28 is 68, so 68 calories. 68 calories is the answer for B. Number 2, multi-step problem. A photographer charges $9.95, that's a fixed cost for a photo session, plus $22 per pose, right, for each pose. Use a verbal model to write an equation for the total cost C in dollars. Okay, so it's basically, it's going to be $9.95 plus 22x. Okay, so that's going to be the total cost. That you can say that's the function or the equation. Total cost C, so you can say the total cost C. So C uppercase equals 9.95 plus 22 P poses. So instead of X, we have P. P poses and total cost is C. So C uppercase equals 9.95, which is the fixed cost, plus $22 times P poses. B, the photographer offers 8 poses. Write an input-output table for the total cost in dollars of a photo session as a function of the number P of poses. Explain why the table represents a function and describe the domain and range of the function. Okay, so this is going to be a long one, but what we have to do here is we have to do the input-output table. So let's see if I can do it here on the side. It's the X, Y, or the input-output table. Or in our case, it's going to be the P and then C. Okay, the poses, 8 poses. So it's, if you have 0, right? 1, 2, 3, 4, 5, 6, 7, 8. 8 poses, and then the total cost is the function 9.95 plus 22p. So we have to calculate all these values here based on this here. Okay, so when P is 0, 22 times 0 is 0, so we have 9.95. If you have 0 poses, the total cost is going to be just 9.95. If you have 1 pose, then 22 times 1 is 22, plus this is 32 minus 0.5, so it's 31.95. Then you can use a calculator for the rest, but this is going to be 44 plus, so this is going to be 44 plus 9.95. This is 53.95. 53.95. If it's 3, you get 66. 66 plus 9.95. This is 75.95. If it's 4, you have 22 times 4, 88. 88 plus 9.95, which is 97.95. If it's 5, you have 110. So it's 110 plus 9.95. it's 119.95. If it's 6, 22 times 6, 132, and then plus 995, 141.95. Then if it's 7, you have 22 times 7 plus 995, you have 163.95. And then if it's 8, you have 22 times 8 plus 995, it's 185.95. So that's the input-output table for 8 poses. Okay. Write an input-output table for the total cost. That's what we just did. Explain why the table represents a function. It represents a function because for each input, we have exactly one output. Describe the domain and range of the function. The domain is 0, 1, 2, 3, 4, 5, 6, 7, 8. The range are these values here, starting from 995 and so on. You have $80 to spend at a photo session. What is the greatest number of poses you can afford? So the total cost cannot be more than 80. So the maximum it can be is $80. So 80, okay, so if C is 80, so the function is going to be 80 equals 995 plus 22p. 995 is positive, on the other side will be negative, so 80 minus 995 or 80 minus 10 is 70, but it's going to be 70.05, right, equals 22p, or p is 70.05 divided by 22, or that is 3 point something. So you can have 3 point something, so the maximum number of poses you can have is 3. Okay, that's for C. Number 3, short response. You plan to put up a wallpaper border in your bedroom that has a width of 8 feet. 8 feet, okay. The area of your bedroom is 96 square feet, okay. The area, okay, area. We have width and length, right? Length and width. Width is 8 feet, so this is 8 feet. The length we don't know. The area is 96 square feet squared, and we know that area is length times width. If this is I don't know, B, width is A, then A times B is the area. So A is 96, A is 8. What is B? B is 96 over 8, or that is 12. So B is 12 feet, or the length is 12 feet. Is 36 feet of wallpaper border enough? Okay, so if this is 12, so this is 12 feet. This is 12 feet. This is 8 feet. This is also 8 feet. So the border is, this is basically the perimeter or the circumference or the perimeter of a rectangle, which is 2a plus 2b. A is 8, so 2 times 8 is 16, plus 2 times 12 is 24. So that's 40 feet of border. That's 40 feet of border, and it's saying, is 36 feet of border enough to wallpaper the bedroom? No, it's not enough. You're gonna be, what, 4 feet short. Okay. Next one, number 4, gridded response. You have a landscaping business. This past summer, you spent $575 on equipment. So number 4, the formula is profit income equals income minus expenses. Your income was $4,850. Okay, what was your profit? So what is P if your income was $4,850 and you spent, or expenses, the expenses were $575. So it's gonna be, we just have to subtract. So it's 4,850 minus 575. The answer is $4,275 is your profit. That's number 4. Number 5, open-ended. Write a problem that involves a real-world situation that can be solved using the formula for profit. Okay, the formula for profit is income minus expense. Solve the problem and explain what the solution means in the situation. Okay, so let's say last year you had income of, I don't know, $5,000, but your expenses were $3,000. What was your profit? So the profit would be 5,000 minus 3,000, or $2,000. Number 6, short response. A car owner records the value of a car every year since its purchase. The graph, okay, this graph right here, shows the value in dollars, right there, y-axis, of the car as a function of t. T is right there, x, or horizontal axis, the number of years since its purchase. What happens to the value of the car as t increases? Okay. Well, as t increases, so 0, 1, 2, 3, 4, 5, as t increases, right? As t increases, the value of the car decreases, right? So for 1, it's like, for 0, it's $12,000, and then 11,000 for 1. For T1, you have probably 9,000. Then for T2, as T increases, this goes down, right? It's 7,000 something. This is 7,000, 6,000, 5,000. So as the T increases, the value of the car decreases. Okay. Is $4,240 a reasonable estimate for the value of the car 6 years after its purchase? So at 5, we have about $5,000. Okay. So at 6, is it reasonable to be 4,200? Yes, it is reasonable, because 4,240 is less than the value of the car at year 5, which is about 5,000. So yes. Number 7, gridded response. You are driving from Orlando, Florida to Miami, Florida, a total distance of about 260 miles. So let's put it right here. So this is number 7. You're driving from Orlando to Miami, a total distance. So distance, D equals RT. That's the formula for distance. The distance is 260 miles from Orlando to Florida. You travel at an average speed. So the rate you're traveling, the average speed you're traveling is 65 miles per hour. Without stopping. How long does it take you in hours to get from Orlando to Miami? So T is the only variable unknown from this formula. So T would be D over R, right? Because R multiplies, on the other side will divide. So T equals D over R, and it's just a matter of substitution. D is 260, 260 over R is 65. So this is 4, because 4 times 60 is 240, 4 times 5 is 20, 240 plus 20, 260. So 4 hours is the answer. It takes 4 hours to get from Orlando to Miami. Using the formula, it's easy to calculate. It's just D over R. Number 8, extended response. You make and sell blankets. The material for one blanket costs $14.50. You sell each blanket for $25. The cost in dollars of the material and the amount in dollars you charge for each blanket are both functions of the number of blankets. Okay, so the cost, so let's do it here. That's the number 8 right here. So the cost of the material, so let's say C, would be $14.50 times the number of blankets. So X, let's say X, that's the first function, and then that's the cost of the material, and then you charge the amount you charge for each blanket. That's another function. Let's say P, or I, is income. I is $25 times X, the number of blankets that you sell. Write a rule for each function. Okay, so this is the cost function, this is the income function. That's A. B, let the domains of the functions be whole numbers from 0 to 5, okay? So we're gonna have basically two input-output tables, X and C, and then another one, X and I. Okay, so 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, and 5. So when x is 0, we have 0 here. When x is 1, we have 14.5. When x is 2, we have 28, 29. When x is 3, let's use the calculator here. So it's going to be 3 times 14 and a half, which is 43.5. And then when it's 4 times 14.5 is 58. And then 5 times 14 and a half is 72.5. And then the next formula, I equals 25x. When x is 0, we have 0. When x is 1, we have 25. When x is 2, we have 50. When x is 3, we have 75. When x is 4, we have 100. When x is 5, we have 125. So it says, let the domains of the functions be whole numbers from 0 to 5. Graph each function. So let's graph each function. So x is 0 to 5. So 0, 1, 2, 3, 4, 5. And then the values go to 125. So let's say 25, 50, 75, 100, 125. Okay. So this is 25, 50, 75, 100, 125, and this is 1, 2, 3, 4, 5, 0, 0. For both functions, 0, 0 are the points, the first points. Then let's draw first this function. So 1 and 14 and a half. So 1 and 14 and a half is somewhere there. 2 and 29. 2 and 29 is somewhere there. 3 and 43. 3 and 43 is somewhere there. 4 and 58 somewhere there. 5 and 72 is somewhere there. So it's like that. Okay. And then the other function is 0, 0, 1 and 25, 2 and 50, 3 and 75, 4 and 100, 5 and 125. So that's the function. This is the income function, which is 25x, and this is the cost function, or 14.5x. So that's B, graph each function. C, you sell every blanket you make. What function gives you a profit? So the profit is income minus cost or expense. Okay. So C, that's the function. How would the graph of this function compare with the graphs in part B? So it's basically I minus C. So I is 25x. So this would be 25x minus C is 14.5x. So, or this would be 25 minus 14 and a half is 10 and a half, 10.5x. So we see here, if we have, if we calculate another x, y input-output table, this being the function 10.5x, and we have 0, 1, 2, 3, 4, 5. When x is 0, we have 0. When x is 1, we have 10.5. So the graph for the profit is it's not gonna be as steep as the other two, so it's gonna be something like this, because it's gonna be 10.5x. Okay. Next is challenge practice problems. There are 8 of them. So graph the functions y equals x over 3 squared and y equals x over 3 cubed in the same coordinate plane. At which values of x do the two graphs intersect? So first we want to try if x is 0, because we know x is in the numerator. So if 0 over any number is 0, so 0 squared and 0 cubed is going to be 0. So x is 0. And then another value is, what if we equal the numerator and denominator, in this case 3? What if x is 3? Then 3 over 3 is 1, and this 3 over 3 is 1. So 1 squared is the same as 1 cubed. So yes, so these two values, at which values of x do the two graphs intersect? They intersect at 0 and 3. In exercises 2 and 3, we refer to the graphs in exercise 1. Which graph is greater over the interval of x values from -1 to 1? So if it's, let's say it's 1, so the first one is going to be 1 over 3 squared, or that's 1 over 9. The other one would be 1 over 3 cubed, or that's going to be 1 over 27. So 1 over 9 is bigger. So which graph is greater? It's going to be the first one, or x over 3 squared. And then which graph is greater over the interval of x values larger than 1? Larger than 1. Let's try 2, right? If it's 2, then we have 2 over 3 squared, that's 4 over 9, and then 2 over 3 cubed, that's 2 times 2 times 2, which is 8 over 3 times 3 times 3, or 27. So this one is larger, right, for 2. But let's try, well, for 3 we know it's going to be the same. Let's try for 4. If it's 4 over 3 squared, it's going to be 16 over 9, and the other one would be 4 over 3 cubed, or that's going to be 4 times 4 is 16, times 4 is 64. So this one is larger. So we can say that larger than 1. So for 2, x over 3 cubed, y equals x over 3 cubed is greater. For 3 we know that they intersect, so they're the same. For any value larger than 3, so 4, 5, 6, 7, 8, the expectation would be that the cubed will always be greater than the squared. So y equals x over 3 cubed is greater. Okay. Number 4, well, let's say in exercises 4 to 8, use the following information. A researcher is interested in studying the relation between the grip strength of a person's dominant hand and a person's non-dominant hand. If a person is right-handed, then the right hand is the dominant hand. If a person is left-handed, then the left hand is the dominant hand. The researcher collects data on 6 volunteers. Dominant hand, we can see the strength of volunteer 1 or volunteer 2, and then the strength of the non-dominant hand for volunteer 1 through 6. Number 4, the question is plot the dominant hand measurements and the non-dominant hand measurements as outputs for the common input of volunteer number. Do you notice any difference between the dominant hand and the non-dominant hand functions? So if you plot this on a graph, you'll notice that the dominant hand is either larger or for volunteer number 3 equal. So the dominant hand would be either larger or equal to the non-dominant hand, the strength of it. So that's the answer for number 4. Number 5, do you notice any trends in the two functions? That's one function. This is the second function. Well, we notice that as the strength of the dominant hand increases, the strength of the non-dominant hand increases as well. You see here 110 and 100. Here is 90 and 85, 50 and 45. So that's the trend that we see in the two functions. Number 6, to better illustrate the difference between the dominant hand grip strength and the non-dominant hand grip strength, what function might you create and plot? The difference. You would try to get the difference between the dominant hand strength minus the non-dominant hand strength, and you'll try to create and plot that function. Okay. Number 7, if dominant hand grip strength is considered as the input and non-dominant hand grip strength as the output, do you have a function? So we know that a function, to be a function, the input has to be mapped to one output. Okay, so 110, we don't see another 110, 120, 150, 85, 50, 90. So in our case, this is a function. Okay, so we would say yes. Now, next question. Suppose the study is expanded and uses 100 volunteers instead of 6. So in this case, we just have 6. So this is a function because we don't have more than one input mapping to different output. But if we have 100 volunteers, okay, do you think it is likely that considering dominant hand grip strength as the input and non-dominant hand grip strength as the output will give a function? I would say hardly, because if you have 100 volunteers, I would bet there is another volunteer, another person that, let's say, has the 150 strength for the dominant hand, but his or her non-dominant hand strength will be not 150, will be maybe greater, or actually it's not going to be greater, but let's say it's going to be less. Let's say it's going to be 145. So in that case, we're going to have an input 150 that is mapped to two different outputs. In this case 150, and in this case 145. So we'll say that no, it's not going to be a function. Okay. So with that, that's a lot of problems that we did. So hopefully this helps you a lot. So if you'd like to see more videos, please like and subscribe to the channel. This was the end of chapter 1, section 1.7, chapter 1. So the next video, we're going to start with chapter 2. See you next time. Thank you. Bye-bye.